Okay, perfect. So let's officially start. Hey, I'm Bartosz. Today I'll be talking about a very interesting audit for which I use AI to generate 2,800 tests, and it allowed to find 22 findings. It's especially interesting because usually AI is pretty bad at auditing, but this is very special case where it was actually the best possible solution. So a little about me. I only look young. I'm doing the hacking for around 15 years. I found quite a lot of issues. And as I said, last year I was talking here about the bug which was allowing to steal $1.1 million. I was very excited back then. But right now I have already 3 such bugs on my account, which, and there's nothing I love more to finding another one. Okay, so like in February, we have a very interesting audit request. It was the audit for Quant virtual machine. And the important part about this is that this Quant project, they were working on some quantum resistant blockchain. And they had this idea that they want to run any kind of the application in their virtual machine. And to do that, they basically were running Alpine Linux kernel and using virtualization, so they could run an application as part of the blockchain. But the problem with this is that if you want to have a smart contract running on the blockchain, it must be deterministic. So on every node, the outcome of the execution must be always the same. And this is actually quite a problem. I will explain in a second why and what could go wrong. But this was the task in general, to find all of the sources of non-determinism in their virtual machine, in their virtualization. So yeah, there are a lot of sources of non-determinism. So, like you have different hardware, different parameters, memory speeds, CPU speeds, and then a lot of non-deterministic functions and features in the system, like threads, memory, clocks, random number generations. There are a lot of them. So it's very important because, as I said, if the node cannot reproduce what the other node did, then you cannot build a blockchain because you always need to have the same result after execution of the smart contract. So just let me show you how many of sources of non-determinism there are, just quickly, because there are like more than 200 sources of non-determinism. Basically everything, what you have in your computer, even like if your disk is having a different speed of reading the data, this is a source of non-determinism, because on some computers it will be faster, on other it will be slower. The results won't be always the same. So quite a lot. And this QVM was using an open source project from Facebook to help with non-determinism. This project is called Hermit. So actually a lot of this testing was testing of virtualization and this Hermit project where they have all the tools for non-determinism. So this was mostly the focus on the audit. Okay, so the scope of the audit was huge. We have those 200 plus sources of non-determinism. It would be a nightmare to test it manually. We would need to hire a team of few auditors. We would need to spend a month to review every potential source of non-determinism. They would need to pay like $500,000 for an audit. So, as you probably know, they didn't have such budget. And the other option, which I was thinking about, was to use AI to check all those cases automatically. And usually it's hard to do audits with AI because in case of the smart contracts, they are not trained on this. There are a lot of different type of the issues which are not known. They are very like project specific. So it don't work very well. But this case was different because actually non-determinism wasn't something new. We have basically this list with more than 200 entries about every potential source of non-determinism. And this is not like a new knowledge. So AI knew how to kind of deal with this. And it was not a new language because they wanted to run any program. It was possible to write just in a C or other language like C++, Rust, Python to test those issues and problems. Yep. Okay, so 1 second. Okay, so before before deciding about if to go with AI or not with this project, let me tell you what is my current experience with, in general, AI and the security. So, I started to, as probably a lot of you, if you are working in cybersecurity, trying to use AI to help with the audits. And initially, there were a lot of projects doing some audits. There were bot races competition on Code of Four Arena, where you had those audits with AI, and the best AI auditor was getting some rewards. But in the end, most of those projects didn't succeed, and a lot of stuff with AI audits and reviews were canceled or banned. And actually, this is currently one of the biggest nightmare of all the platforms with where we do this bug bounties of crowdsourced audits, that they need to ban all the reports from AI because it's generating so many of them that it doesn't work well in the practice. It doesn't work well because there are plenty of issues, which I will talk about in a moment. Okay, and here's the interesting story about me trying to cooperate with OpenAI on this project. So 2 years ago, OpenAI launched after the GPT-4 something called OpenAI Cybersecurity Grant Program. And I submitted an idea to build AI Solidity Auditor for the grant. And interestingly, we got to the second round to the program. And we had this amazing meeting with OpenAI team. Everything was great. They were supposed to give us the credit and access. But this was the last time we were able to talk with them, because then they stopped answering any emails and didn't follow up. So this was pretty sad. But it was due this time when when they had those issues with some Altman being kicked from being a CEO and stuff, and a lot of people get fired. So that's probably the reason. But one interesting thing is that, look at this, 3 weeks ago, after 2 years, they responded to me that, sorry, but your application didn't make it. So, only took 2 years, but thank you, OpenAI. And yeah, so they starting this program again, but I don't plan to apply. But if you are doing something with AI and cybersecurity, feel free. Maybe they will reply sooner. Okay, so let me explain you what is the in general problem with AI and audits and coding, which not many people talk about. Unfortunately, a lot of people who post about AI, the stuff on Reddit and LinkedIn, don't work with AI, and are usually just posting not something they tested or did themselves, but those things usually don't work in practice. So we need to remember that AI is, okay, we can argue about this, but don't argue with me, just, we can take the screenshot and argue with ChatGPT on this, sorry. Okay, so yeah, we need to remember this is pattern matching still. It's not like intelligence. It's hard for it to understand what's going on in like smart contract program to see every edge case. There's a lot of problem with context when it comes to AI, because usually when you talk with AI and test something on like a small prompt, let's say a few thousand words, it works pretty good. But when you start to having a longer conversation, you upload more code, the quality quickly goes down. And a lot of benchmarks don't show it. They are working with small subsets or small problems. But when you check the benchmarks, which are testing things which are like 100,000 tokens, which is like a complex smart contract, the quality drops a lot. And this is a very important thing. For AI, usually it's hard to, in case of Solidity, AI usually is not teach how to deal with Solidity, and there are not enough examples. So it's hard for it to understand what's actually going on, how to write good code. This code which they have is often outdated. So you need to give AI all the instructions in the prompt, but you end up quickly with very large prompt if you want to explain everything. And then you basically need to explain every issue in the prompt, how to look for this, and how to detect this, and this usually works only to very few limited issues, and and there's no something like training for a given programming language. Okay, in theory you can train AI, fine tune it, but it's not usually what the people say. And first, you need to usually work with the best models to get the good results, and then like training them is usually impossible. But even if it is, it's a huge cost, and there's just even not enough data to train them for working with Solidity or auditing in general. That is quite a huge issue. And there's another thing which is very important for AI and testing. If you want AI to do something right, correct, you need to have a way to verify if it's going into a good direction. So the problem when it comes to the issues is sometimes it's hard to even define what an issue is. There are simple issues like, let's say, crash or like some authorization bypass, but then you got a lot of more issues, like, for example, reward stealing or getting some advantage or getting more votes than you should. It's very hard to create a simple definition to cover everything. So this is quite a huge problem. And the last thing which a lot of people working with AI, myself as well, are falling for is the reproducibility trap. By this, I mean that it's very easy to convince yourself that something is working correctly with AI and it's solving a hard problem which you have. But this is because, if you try very hard, if you try different approaches, prompt, instructions, finally you will find a way to solve the given problem you have. But it doesn't scale. If you try to apply the same logic with next 10 or 100 projects, it won't work. When I was doing stuff with Solidity, the simple example was that, okay, I managed to find some issues like reentrance or some economic issues, but if I only change the order of the functions in the prompt, it was working exactly the same, just a different order of the functions. It wasn't able to find those issues anymore, and there are many traps like this. So that's problem with AI ideas in general. Okay, but this case is different. We are trying to find all the sources of non-determinism in the virtual machine. And the thing is, first of all, it's a well-researched field. It's not like there are some unknown new sources of non-determinism in Linux kernels or hardware of computer. Basically, everything what can be found was already found, detected, and documented somewhere, at least 98% of cases, which is enough. And we can easily verify if the AI found a correct thing or not. Because we can just write test and see if the output, the result of the test was not non-deterministic or not. So this is another thing, because we can define what the success is. And then we have a standardized environment. We have this virtual machine on Linux kernel, on QEMU virtualization. We can run it across multiple machines many times, so it's easy to build this testing infrastructure. And we can also write with standard language like a C, which is something that AI knows well about. So a perfect case. Okay, so our strategy was to have 5-step plan. First of them was to gather all the data about known sources of non-determinism, which in this case was basically using all the AI tools, deep research, and doing all the research about non-determinism, like checking every category, telling AI to think deeper, search more, like check the POSIX documentation about the functions, which of them can be non-deterministic or not, check all the hardware sources of non-determinism, everything. We did like 100 deep researches. But that was out of the data. So the step two was to organize it somehow. So remove the duplicates, organize it into categories and subcategories, which we also did manually in this case. We ended up with like 270 subcategories of non-determinism, quite a lot. So then we started to automate the next steps. And I want to say that, this project was co-created with my friend Yuri, who was responsible for coding this Python implementation. They later will be a link to the repository because this code is open source, and you can find details about Yuri in the description. He gets a lot of credits for this project. Okay. By the way, I met him last year on the ETHWarsaw, and he didn't know anything about the Web3. Yep. Sometimes, you meet interesting people here. Okay, so we started to write a code in the Python to make it work. And the first stage of this AI agent was a planner. So we have all those categories, subcategories. Now we need to have some plan how to deal with them. So for every category, subcategory, we define what we're going to test in given category and subcategory and how we're going to test it. So for each of them, we want to have proposition of at least 5 tests which will be run. And all of them should be different. So after running this planning engine, we end up with 76 categories and 240 subcategories, and each of them had at least 5 test proposition what to test. So yeah, quite a lot of them. That's when 2,800 tests come from. Okay, so the next step was to actually execute those tests. So that was the goal of execution agent. So for every category, subcategory, and test proposition, the execution agent was generating the code. It was able to generate the code in any language, but we mostly did it in C because C is the easiest to test some very hardcore functions when you need to interact with some CPU like assembly instructions. So it was the best for this. So yeah, it was generating the code. It was executing this code across many nodes. It was validating. If the non-determinism was found, then the test was marked as successful and was moved to the next phase, next stage. But if it wasn't, if the test was deterministic, then AI was given a few another tries to somehow improve this test something different to make sure that this non-determinism is detected. So yeah, it was all configurable. So it was in the end up to configuration, how many tries and tests you want to run. Okay, so this execution agent created those 2,822 tests, mostly in C. So yeah, there were quite a lot of them. And we were using back then mostly DeepSeek and Cloud Sonnet for writing the tests. And it worked amazingly well. Usually it was able to create valid programs in like 2 runs. So first it creates the program, then we check with CLang compiler if there are any issues, if it compiles. And if there were any issues, it was getting prompts to correct them, and it was usually able to correct them pretty easily. And this is this important thing about why it was a good case, because AI is trained on a lot of C programs, so it knows how to run them, and there's no any innovation which it needs to test, because 5 years ago the technology for those testing when it comes to C would be exactly the same. So we don't need to give AI any new instructions how to interact with this. It was already there, so this was perfect. Okay, so yeah, we have the test. And around 400 of those tests were resulted in non-determinism or some issues. And that's quite a lot of tests. So sounds like another month just to verify them and what is the source of non-determinism in those tests. So we had to create another stage, which was review agent. And in this stage, the AI agent was basically running those tests and trying to find out what is the source of non-determinism in this test by removing some code and checking if the test still fails or not, and then trying to find this exact one or 2 lines of the code which are responsible for the problem. And after running this, it was able to categorize everything into 22 separate issues. And we had 11 issues, which were problems with Hermit, this open source execution environment from Facebook. And those were crashes and panics and aborts, which was pretty surprising for me because actually it was amazing that, this approach, this was able to find a lot of issues in other projects which we weren't even trying to find because we were looking for non-determinism, but it was finding crashes and real bugs. So it was like fuzzing with AI. So that was pretty surprising. And it also found 11 sources of non-determinism, like, there were a lot of them. So yeah, I mean, you really need to be a geek to, I think, if you want to listen about them. So let's skip about this. Okay, so yeah, we created a final report, which is available on Hacken website. If you go to Hacken Audits and you will enter Quan, you will find the report where you can read about all the issues which were found and what was the problem. So yeah, 22 findings, and it was all done in around 2 months, where we spent like 1 month on working on this AI stuff. Other time we were spending just on manual audit because it wasn't only AI audit. I was also checking a lot of things manually, just to be sure. And then they were able to fix all the issues, which is quite a big accomplishment. So yeah, after a month of time, they came back with all the issues patched. And this is another great showcase why this approach was pretty good, because we just rerun all those tests and this tool again on a new fixed code base. We didn't need to verify everything by hand. We just rerun what we had, and it all worked. It didn't find any new issues, which was an impressive job done by the Quant team. Okay, so yeah, what we managed to achieve with this approach. So first of all, we saved a lot of time. Instead of 500,000 audits, we made it for much less. And it's not like we don't like money, I guess. They just wouldn't be able to afford this. And we get a superior coverage. So a lot of things were tested. Basically, every POSIX function, every source of non-determinism, even some hardcore function like vector operation or assembly functions or some built-in CPU randomness was found and tested. So that was amazing, and it would be very hard to do manually. And this tool was reusable and future-proof. So, whenever you change something in your implementation of the virtual machine, add new features, you can always rerun it again to try to find out. Maybe you made some mistake, and now it will be able to find it. So yeah, this is a perfect thing because, write once and use kind of forever. Okay, so that was it when it comes to this audit. But let me probably, out of you wonder how the future looks like when it comes to AI and the audits. So in general, from my experience, AI won't replace the human auditors because when it comes to working with a new stuff, which was just created, and there are not very examples, there are a lot of edge cases and a lot of interactions and things to account for. It's extremely hard for AI to do anything with this. That's why we don't have any good projects right now. In general, I have a lot of problems with memory. This is the biggest problem with AI right now, that you cannot really teach it something new, and it doesn't really remember what you were doing with it before. That's why we don't have any AI agents who work like a personal assistant who knows you and can recommend what you are doing. And if they are usually very limited, and they quickly start to make many mistakes after some time, like a month or a week. So yeah, so AI is more like a tool which just will speed up all the work, maybe testing, maybe confirming some issues. But it's for sure not immediate risk for the senior developers and senior auditors. I mean, we need some breakthrough in AI memory to, let's say, be in danger when it comes to this. So, when AI assistants will start to be a norm and they will be very good, this is the moment where you need to start to be afraid if you are working in this field. So this is how I see it. Okay, that's all. Thank you for listening. I hope you enjoyed. And we even have a few minutes for questions, do we? Perfect. First question. I will check if I have this links to repository somewhere. Yeah? Hey.
Doesn't matter. So my question.
Oh no, it's working now.
Yeah, thanks for the presentation. My question is, in these steps, like what was the orchestration tooling that you were using to do this? Or maybe it doesn't matter. Second question is like what kind of agents you were using. So nowadays you have this Claude Code and Codex, which maybe you didn't have before. So for the agentic behavior, what did you use?
Mm-hmm.
Was it in-house? And third question is a human in the loop, like how much human was involved in each of these steps and at which stages, if you can clarify those parts.
Okay, sure. So when it comes to the agent, we were using, I don't remember the name, but back then there was no Cloud Code. We were using some different tool to write this code. Come on, Aider. Yeah, we are using the Aider implementation to write the code back then, but it wasn't like necessary. We were just, we were having few defined steps of interactions with AI. Like, okay, first you write the code, then we run this code, and if there are any issues with this code, we just send you back the issues and now write the new code which will correct this. And for the other step, like with the categories and subcategories, we are usually using just a single prompt for like 2 or sometimes more. Like the first prompt is, okay, propose the categories, then criticize it, like think what could be done better, and then implement the new version. And it was just done by using structure output. So it's not like there were some advanced agents used in this, just interactions with AI, mostly with this DeepSeek and later with Cloud Sonnet, which worked pretty well. But right now, if I had to do it, I would probably use Cloud Code because it would be cheaper, but it would take way longer. That's the problem, because it would take like probably 2 weeks with a Cloud Code to run all the tests. So, but it would be probably much better. It will depend on the budget. If there were other questions, you need to repeat them. Okay.
Awesome. I think we have time for one more. You were next.
I was wondering, when you were using AI for the fuzzing, you mentioned it briefly, but did you run into anything where it was hallucinating, returning different results each time you went through? Did you have a set number of did you run it a set number of times to try to reduce that, or how much of that part of that was?
Okay, so of course, and a lot of times AI was doing stupid mistakes and something wrong. But here we had this advantage that we are able to verify if it works and if it's doing a good job. Because first, is writing the C program, and this program needs to compile and run. So this can be verified. If it doesn't compile, then we tell it about the AI and it gets another try. And then we have the results of the execution of the program. So we can get this output of the execution, this std out, and we can see if it caused non-determinism or didn't. So, if AI was starting to hallucinate or doing something wrong, and the tests weren't compiling and were passing, then it was informed that it's doing things incorrectly. So that's why it works in this case.
Okay, I think one last one. Okay. 1 minute.
I will answer you.
Okay, thanks for your presentation. I want to know that how to use AI agent to audit the on-chain system, but not as a single smart contract, which means that consider on-chain system, you must to deploy your AI agent on every node of the whole network, and then it may contain some interaction with these AI agents on each node, to analyze to get the data and analyze the network traffic or something else. How to do that?
I don't know. I don't have experience with something like that. And in general, when it comes to blockchain and AI on chain and some trading agents, I know nothing about this.
Sorry about that.
So yeah.
But anyways, thanks for your presentation. And I think I would like to get some answers, maybe from anyone here who has experience or some or external experts. Okay, I got it.
Awesome. Thank you so much. Thank you,
you.
Bartek.